Hello and welcome. In today's video, we will discuss about pre-training of LLMs. So large language models or LLMs have changed how we think about AI, especially in how machines understand and generate human language. One of the most important ideas that made LLMs possible is something called pre-training. In this video, we will break down what pre-training is, how it works, and why it matters. Let's begin with the basics. What is pre-training? Imagine trying to teach a child everything from scratch, mathematics, science, and languages every time. That is how old machine learning systems used to work. They were trained for just one task like translation or summarization, and they needed a lot of labeled data for each job. But what pre-training changes in the above approach? Instead of building a new model from the ground for every task, researchers found a smarter and efficient way to build one big model and train it on a massive amount of general data. First, this model becomes a kind of universal brain that has all information. Later, we can just adjust it slightly. That's called fine tuning. This idea of building a foundation first, then customizing it is what we call the foundation model approach. It's like building a Lego base that can be reshaped into different tools as required. So, we train a model on massive data before specific tasks that acts like a universal language brain. So before pre-training, let's discuss about a brief bit of history. Even though pre-training became popular recently, it is not a new idea. Back in the early days of deep learning, scientists were already thinking about training models without labels. So techniques like autoencoders and early neural networks were steps toward this particular goal. But things really took off with the development of word embeddings, a way of tuning words into numbers that capture a meaning. Tools like word to vec and GLOVE helped models understand words by placing them in a kind of meaning map. Later, more advanced models like BERT and GPT came along. These models didn't just learn about single words, they learned how words work together in sentences and conversations. And they did not need humans to label data for this. They used something called self-supervised learning, which is just a fancy way of saying let the model figure things out by itself using patterns in text. So each AI system needed custom labeled data and no knowledge shared across tasks before pre-training. So let's move to how and what self-supervised learning is doing. Train without human labels. Model predicts missing words in text. For example, if you give a sentence, the cat sat on and then leave a blank, it will predict the probabilities of placeholder for the blank. So now let's look into how does self-supervised pre-training work. Take a sentence like the cat sat on the mat. Now imagine hiding a word. The cat sat on the blank. The model's job is to guess the missing word. By doing this over millions of sentences, the model starts to understand grammar, word relationships, and even some word knowledge. This task is known as masked language modeling, and it's one of the most common pre-training techniques, especially used in BERT. Another approach, like in GPT models, is to predict the next word in a sequence, kind of like autocomplete. Both methods fall under the same umbrella of self supervised learning. The key idea is the model teaches itself using raw text, no labels, no human help. That is how self supervised pre training work. So let's now look into the types of architectures, the more popular architectures of pre trained learning. So as we see here, we have three types of main pre-training architectures. One is encoder only. For example, BERT. These focus on understanding the input. And the second, decoder only, like GPT, which is good at generating text summaries. And the third, encoder decoder models like T5. This does both the operation read input and generate output. For example, read the input text, translate it, and give you the translated output. Each of these has its own use cases. As we have seen, BERT is great for tasks like classification, while GPT shines in tasks like writing essays or answering questions and summarization. Let's move to why is pre-training so powerful? Because less label data works with zero example saves time and computing. Pre-trained models are so powerful because they already know a lot about language before we even ask them to do a specific task. That means we do not need as much label data. Instead, we can fine tune the model on a small set of examples, or sometimes not at all. This is called zero shot or few shot learning. This is why you can ask ChatGPT almost anything and it gives a decent answer. Pre-training also saves time and computing power in the long run. Training from scratch for every new task would take forever. But with a pre trained model, we are just tweaking what is already there. Let's see a real example. BERT, one of the best known pre trained models developed by Google, is BERT. It stands for Bidirectional Encoder Representations from Transformers. That is a mouthful, but the keyword is bidirectional. It means BERT looks at both the words before and after a target to understand the context. For example, in the sentence, he went to bank to deposit money, BERT looks and knows that bank here means a financial institution, not the side of a river. BERT was trained on huge amounts of English text and then fine tuned for all sorts of tasks like sentence classification, question answering, and text matching. So let's move to the next, fine tuning and prompting. Fine tuning is to adjust model for new tasks. Prompting is to give smart inputs to get expected output summary without retraining. Supports wide range of natural language processing applications. So let's discuss more about adapting pre-trained models. Once a model like BERT is pre-trained, we can adapt it to do specific things. There are major ways we will discuss two of them. One is fine tuning, as we have seen before, and second is prompting. Adding new layers to the model and train it a bit more on a new task is nothing but fine tuning, whereas prompting is give the model carefully designed text input so it knows what to do without changing the model itself. So both of them are for solving different problems just by changing how we interact with it. So now let's look into challenges with fine tuning. Risk of forgetting old knowledge and needs careful balance and data handling. So fine tuning is powerful, but it's not perfect. If you fine tune your model too much for one task, it can forget how to do others. This is known as catastrophic forgetting. Researchers are still exploring ways to prevent this kind of problem, like using older data during fine tuning or using techniques like experience replay. Let's look into pre training beyond natural language processing. Although the pre training started with language, it's now being used in other areas like computer vision and speech processing. For example, vision models are trained on millions of images and then adapted for things like object detection or image captioning. This shows that pre-training is not just a trend, it's a general method that can work across AI. So beyond language, it can be vision, speech, and many more. So let's summarize about pre-training. Pre-training has completely changed the way we build AI systems. Instead of building narrow one task models, we are now building powerful general models that can learn from the world and then be adapted to all sorts of jobs. We are still early in the journey. Truly intelligent machines are still a work in progress, but thanks to pre training, we are much closer than we are before. So, the next time we ask any prompt to ChatGPT, a question, or a translate something online, remember behind the scenes, a powerful pre trained model is hard at work. If you enjoyed this video, don't forget to like, subscribe, and leave a comment if you want us to explain more topics from this particular topic. See you next time. Thank you for watching.